So dear students, again I am going to explain you the next experiment, that is experiment number 2, how to perform that experiment on the virtual lab platform that we had discussed in the previous video for the lab classes. So again we can use the Google search engine for searching this virtual lab. Here you will click and you will obtain that virtual lab platform. So this virtual lab platform, once again we have received just like your previous practical. So coming to the link of communication, electronics and communication, let's open it. Then coming to the basic electronics lab, here again the list of experiments. So we have this list of experiments, and today we'll be performing this half wave rectification. So in the aim you have to write the study of or to study half wave rectification process using a PN junction diode. So this theory is there for you to study. We have already covered this portion in our course. So we have this input waveform, sinusoidal input waveform, and the rectified output waveform for a half wave rectifier. So this is the various formulas for calculating the peak value of the AC voltage, then VDC, and then you can also calculate the value of form factor, okay, then ripple factor. This ripple factor is form factor minus 1. This is the formula for calculating the value of ripple factor. So using this you can write this portion, you can write the theory part for this experiment, but you have to write this theory in very brief. Not more than one paragraph is required. Okay. So coming to the procedure, here your procedure is given, what you have to do and what are the steps that you have to follow. First of all, you have to set the resistance RL, the value of the resistance RL. Then you have to click on button to start the experiment. Then you have to click on the sine wave button to generate the input waveform. Then you have to click on the oscilloscope button to get the rectified output. You can vary the amplitude, frequency or voltage per divisions using the controllers provided. Then you can click on the dual button to observe both the waveforms, that is the input and the output waveforms. Okay. The channel 1 shows the input sine waveform, and the channel 2 it will show the output rectified waveform. Then you can calculate the theoretical value of the ripple factor. Fine. And you can also measure the value of ripple factor from the curve. So let's start with the simulation here. So we will start with your half wave rectifier, this half wave rectifier. So here again you have the value of, you have this instruction. You can, if you put the cursor here, you can see the steps of the instruction. First of all, we have to set the value of the resistance RL. So here we can move this slider and the value of resistance RL will be adjusted accordingly. So let's keep the value of RL as 200 ohms. Then what we have to do, then click the on button to start the experiment. We have to click the on button. Here you will find this on button. We have to click in order to start the experiment. After that we have to double click on the sine wave generator to generate the input waveform. So this is here you have this sine wave generator. You have to double click on it. This input sine wave form has been created. You can see here. Now you can adjust the position of this input waveform. It can be placed vertically, vertical position, and you can also change the position Y for channel 2. But here in channel 2 we don't have any signal, so it's not showing there. So then we have to again see what is the next step. Click on the oscilloscope button to obtain the rectified output. So here you have to click on the output button. So here you will find the calculations. The calculations is your peak current is this much. So here this waveform, you will see this waveform is the half rectified wave. Now if you again vary the amplitude, frequency and the voltage per division using the controllers. So these controllers are given, they are given to change the frequency as well as the various positions I have told you for these waveforms. Okay. Now here the frequency is 1000 Hertz, but you can change the frequency. I think this is your again 1000 Hertz. You can increase the value of frequency or you can decrease the value of frequency using this slider. Okay. If you want to increase or decrease the amplitude of this waveform, you can use this. You can use this slider for changing the value of amplitude. Okay. So next is again, if you want to see both the input and the output waveforms on the same graph, here you can click the dual and you can change the position of waveform. This is your input waveform. It is simply overlapping, so this portion is not visible. Actually it is overlapping behind and this portion is there. So this much is your rectified. We can bring it down a bit here. Okay. So this can be used for adjusting the position, or we can adjust the position of the second channel like this. So these two waveforms we can obtain. Then finally we can calculate the ripple factor. We know that the theoretical ripple factor is 1.21 and we can find the value of the ripple factor, and we can trace the virtual oscilloscope. We can trace the reading of the virtual oscilloscope on the trace paper, or simply I think it's given. Let's see. So here from these formulas you can calculate the VRMS, then VDC, then ripple factor and the value of peak current. Fine, because we have the load resistance R. So the peak current is automatically calculated. This one 4.499. You can write this as result in your experiment, and you can draw these two waveforms and you can write the value of ripple factor. So this is how you perform the second experiment, that is half wave rectifier, or understanding or study of half wave rectifier and calculation of ripple factor. So you can use this virtual lab for doing other experiments also. I'll be coming with the videos for other experiments very soon. Thank you.